Hi! This video is for Chapter 3, talking about measures of location. So the different measures of location that we're going to look at are the mean, which is just the average, the median, the middle value in a sorted list, the mode, which is the most frequently occurring value, percentile, which is a percentage of values that are less than a specific value, and a quartile, which is a boundary for the lowest 25% or the highest 25% of the data values, and these are just a special case of percentiles. Now we're not really going to talk about how to calculate a mean. Pretty much everybody knows how to calculate an average, which is just the same thing. So first of all, the median. This is just the middle value when the original data values are arranged in order of magnitude. So they're either arranged in increasing or decreasing order, and you just take the value that's in the middle of the list. The reason that we sometimes use the median instead of the mean is that the median is not significantly affected by extreme values, where the mean can be. So to find the median in a set of data, you would first need to sort the values or arrange them in order. Then, depending on whether the number of data values you have is odd or even, you do a little bit different thing. If the number of data values is odd, then you can just pick out the number that's in the middle of the list. However, if the number of data values is even, then there are actually two numbers that are in the middle of the list. So you find those two and average them. So here are some examples. We want to find the median of this list of numbers. So first, we look at the fact that there are 6 of them. That's an even number. So once we get our list sorted, we're going to want to take the 2 in the middle and find the average of those two values. So first, we're going to sort them from smallest to greatest, and then we pick out the 2 that are in the middle of the list, which would be the 0.73 and the 1.10. So we're going to take those 2, add them together, and divide them by 2 to get the average. So our median is going to be 0.915, and notice here that we round to 1 decimal place more than what we had in our data. That's kind of a rule of thumb. Here's another list of data, and notice that this one is almost the same except it has 1 extra value, so this list has 7 data values in it. Since it has an odd number of values, all we have to do is arrange it in order and then take the one that's in the middle. So here's our sorted list. The value that's in the middle of this list would be right here, the 0.73. So that's our median. Next, for the mode, this is just the value that occurs with the greatest frequency. So if there's a value that occurs more than once, then the value that occurs the most times will be the mode. Now sometimes there is no value that occurs more than once. In that case you would have no mode. Sometimes you only have one mode. There's one value that has a higher frequency than any of the others. Or if you have some values that are tying for the greatest frequency, then you can have more than one mode. One of the places that we use the mode the most is if we have nominal data. In other words, only categorical data that has no numerical values. In that case, the mode is the only measure of central tendency that we can use, because the mean and the median wouldn't have any meaning in those cases. So here's a little bit more terminology. If you have a data set that actually has 2 modes, 2 data values that tie for having the greatest frequency, we call that bimodal. Multimodal would mean that it has more than 2 modes, and it has no mode if there's no data value that's ever repeated. So here are a couple of examples of finding the mode. If you look through this list, you will notice that the value 1.10 occurs twice. It's the only one that occurs more than once, so it is the mode for this set of data. In this list, notice that the value 27 and the value 55 both occur 3 times. So they're tied for having the greatest frequency. That means both of them are modes, and this is a bimodal data set. And finally, we have this set of data. If we go all the way through, we see there's no value that's repeated, so this set has no mode. Okay, on to percentiles. And again, a percentile, if you're looking at a list of data, then the percentile value of a specific data value means that there are that many percent of the other data values that are less than it. So to actually calculate the percentile of a specific data value in a list, we find the number of values that are less than that data value, divide by the total number of values in our list, and we multiply by 100 to get it into a percentage form. Once we have that, we round to the nearest whole number. So here's an example of calculating that. Here we've got a list of 15 values that are a random sample of all flights of a space shuttle program and the duration in hours of those flights. So if we want to find the percentile for the value 191 in this data set, which is right here, then the first thing we're going to need is to sort this list from smallest to greatest. So here's our sorted list, and we find where our value is that we're interested in. 191 happens to be the fifth value in this sorted list. That means that there are 4 values that are less than it. So we're going to use the formula at the top of this slide. So we're going to divide 4 by 15 since there are 15 values altogether in the list, multiply that by 100, and when we do that we get 26.7. We're going to round this up to 27. That means that 191 is the 27th percentile for this data set. Now if we want to go the other way, which we frequently do, if we want to look at a list and we want to know the data value for a specific percentile. For example, we commonly want to know the data value that marks off the 25th percentile or the 75th percentile. So again, the first thing we have to do is sort the data from smallest to largest. And then we're going to calculate an index, and this index will tell us the location in the sorted list of our percentile value. So the way we calculate the index is that we take P, which is the percentile value that we want, divided by 100. We multiply that by n, where n is the number of data values in the set. If the I that we calculate turns out to not be an integer, we have to round up. Even if it's, say, 6.01, we would have to round it up to 7. This would give us the position in the sorted list of our pth percentile. So if we rounded it up to 7, then that would tell us that our value was going to be the 7th one in the list. If I turns out to be an integer, then we have to go halfway in between that position and the next position up in our list. So for example, if I turned out to be exactly 7, then we would look at the 7th and the 8th positions in the list and average those two values to get our pth percentile. So here's another example. This time we have our same list of flight durations, but we want to find the 75th percentile for this data. So we want to find which value in this list would be at the 75th percentile location. Again, we have to sort the data first. So here's our sorted list. Then we're going to calculate I, our index of position. So since we want the 75th percentile, we're going to take 75 divided by 100, and we have 15 data values in the list, so we multiply that by 15. That gives us 11.25. And again, we use 15 because there are 15 values in the data set. Since 11.25 is not an integer, we're going to round it up to the next one, which is 12. That tells us that our 75th percentile is the value in the 12th position in our list, in our sorted list. And that would make it 266. So our 75th percentile is 266. Now finally about quartiles. Quartiles, as I said, are just a special case of percentiles, and these basically divide the list of data into 4 pieces. So we have our first quartile, which we usually see written as Q sub 1. This is the same as the 25th percentile. So 25% of the data is less than the first quartile. Our second quartile is Q2, and this is the same as the 50th percentile. And notice that this is also the same as the median, because this means that 50% of the data is less than Q2. Finally, our third quartile, Q3, is the same as the 75th percentile. That means that 75% of the data values are less than Q3. It also means that 25% are more or greater than Q3.